Okay, so we're going to look at interpret slope using real context. That basically means with units. Okay? Just in case you forgot, I'm sure you didn't. Rise and run. We're going to add a little bit of notation. Change in y over change in x. Vertical, horizontal change. y2 minus y1, x2 minus x1, right? Just slope. Okay, so the first one is if we look at slope as a ratio, it's important that x and y have the same units. Which means you might need to convert the information. So if I say 1 to 12, okay, y to x, that's, and I'll give it units, 1 inch to 12 inches, all right? It's a ratio, so the y goes first here. Okay, this is kind of relevant because they're renovating the school, but you guys won't be here. The maximum recommended slope of a wheelchair ramp is this. That is actually true. Okay, it's a ratio, 1 to 12. 1 foot, 12 feet. 1 inch, 12 inch. 1 to 12, that's the ratio. Okay, a business installs a wheelchair ramp that rises 22 inches over a horizontal length of 24. Is it steeper than recommended? It's the question. See if you can use the ratio and show a comparison that will answer that question. (24) 22. Notice that we've got feet and inches. Okay, if you got A, try B and C. Answer should be no, yes, no. Answer's no, right? Answer's no to this one. Okay, so 24 feet, I'm going to convert to inches, is 24 feet is 200 and 88 inches. Okay, so the rise is 22, the run is 288. Now I can reduce that, I notice, but I can also just convert it to a decimal. I'm missing a 0. 0. Okay. Compared to 1 over 12.8083. Is it steeper than recommended? Which one is steeper? The bigger one, right? The bigger slope is steeper. So this is it steeper than recommended? No, that means that it passes the ADA. Means it meets the standards of how steep the wheelchair ramp can be. Okay? Same situation. It's all about a wheelchair ramp. Answer B, and then I changed the question to C. Right? Show your work in a clear, organized way. As long as the units are the same, the ratio will work. So you can convert it whichever way makes more sense to you. Ratios are like proportions. You can set them equal. Ramp that rises 27, so I have 26 feet. Here's my ramp, and it goes up 27 inches. Right, there's my diagram. Over 26 feet, up 27 inches. Is it steeper than recommended? Somebody asked if you can convert to feet instead of inches. Sure. They just have to be the same units. Okay, so 27 over 312. 0.086 compared to, okay, so it's too steep. That means you have to make it longer, right? It has to cover more distance to make it less steep. But how long should it be? If you have to go up 27 inches, how long should the ramp be? Right? You have to go up 27 inches. How long, right? Now, how much distance does it cover? How long should the ramp be? It's a multi-step process. You might have to find more than one unknown. I'm going to label our X's and Y's differently. Okay? The only thing you know is that it has to go up 27 inches. What's my horizontal distance supposed to be? How long is the ramp actually going to be? You have two steps. First, you have to find X or Z. Then you have to find the other variable. Last year I made them go measure the wheelchair ramps in school to see which ones met the guidelines. Some of them failed. But maybe that's because their measurements weren't accurate. Ratios are proportions, yes. Okay, so you know that this is 27. You know that it has to be 1 to 12. Which one is 1? Which one is 12?
That's 1.
Set it up like, so I know that it has to eat. Now it could be less than, right? But let's just go with equal, right? It's too steep. So I want to use the least amount of material. Exactly right. The only thing I know is that that has to be 27. All right, ratios are like proportions. Find your x. That's a right triangle, guys. Find your hypotenuse. Think about how you would round if you need to. Don't make the ramp too short, right? Don't make the ramp too short. It won't meet the guidelines. So if you have to round it so that the question would work. Doesn't matter, as long as you label your. Let's see what we get. 12 times 27. So x equals 324 inches, right? Mine is in terms of inches. Units matter. Okay? So if this is 324.
I'm just going to go measure the stairs.
Not yet. Okay. So have a seat. Okay, x squared plus 27 squared equals z squared. Okay, 324 z squared. Okay, squared plus 27 squared square root. Okay, so I get 325.123 equals z, right? And that's obviously rounded, but don't make it too short. It means you can't round that to 325. You would have to round it up. It doesn't matter what you round it up to, but you can't make it shorter than this. Then the numbers wouldn't work out, okay? So I'm going to say approximately, if I were building this, maybe I'd make it a ½ inch. Maybe I'd round it all the way up to 326. But don't make it too short. Inches. Let's divide. Or 27 point, I'm rounding up, feet. But 27 feet would be too short for the ramp. Notice that this is actually that slanted distance here. Okay, anyone know how tall the average stair is? All right, there's building guidelines. If you go downstairs that are not the right height, you notice. Okay? If you go down the stairs of an old house or in a basement, you're like, why does this feel weird? It's because they're not the right height. There's building guidelines. So I think average stairs are between 7 inches and 11 inches, depending upon where they are or when they were built. Okay, and building guidelines change. So you can pick any one of those heights. Okay, figure out how long, right? Have you ever had to make a wheelchair ramp or like add accessibility to an existing building. How tall are the stairs? How long does that ramp have to be? Okay, so assume that we have, I don't know, maybe like a porch. You have 3 stairs leading up to your house. How long is that ramp going to have to be in order to make it accessible? Okay, show your work. 3 stairs. Trying to build a ramp that's going to go up 3 stairs. How long should it be? That's why we have a ramp in the back of the math hallway, right? Because the level changes. Right? We have stairs here, but a ramp on the back side. Has to be accessible. Maybe start by drawing a diagram of what you want. Where's the ramp going to be? This is just slope as a ratio. Right? You can draw rise and run, but you're just making a triangle. You decide how tall your stair is, right? Average is between 7 and 11 inches. Show your work so that I can follow it. So 7 inches, so it could be 21 inches to 33, right? Minimum, maximum height. Okay. Ramp. I'm just going to draw my ramp off this way. Okay. X and Z. So I'm going to do a minimum and a maximum. Your answer should be somewhere between this. Minimum, right? So we're going to go with 21 vertical change. Maximum, 33. Just depending upon how tall the stair is that you're choosing. Okay. Inches, inches. Okay. Could the ramp, how long should the ramp be? So a little bit of Pythagorean theorem. Okay. Oh, okay. So Z is approximately 252.87. It's like almost the exact same horizontal distance. It's almost, right, but you don't round down, makes it too short. So you'd have to round that up 253 inches. Right? What measurements do the supplies come in? Maybe they just round up more because it's easier not to cut the material. Doesn't matter. It just depends. Okay, so 396 squared plus 33 squared. Okay, equals z squared. So z is approximately. This one is also the same, just barely longer. 397.5 or 398. But you should still show the work. Even if you're going to round your answer, show the unrounded answer and then box whatever answer you're going to use. Now, depends upon how tall the stairs were, what size ramp you would use. But that's how much material you would need. So 33 feet. That's a lot of ramp to go up 3 stairs. Think about the football stadium. You have the bleachers, you have the ramps that go back and forth because you have to cover a lot of distance to go up a certain amount of height.